Okay, fine, Ifra. So in 10th mathematics, let me just check with the syllabus. The first number is real number, right? Have you studied anything, any lesson of maths before for 10th standard?
Yeah, we've completed 3 chapters.
Okay, what are those?
Real numbers, polynomials, and linear equations in 2 variables.
You've completed real numbers, polynomials, pairs. Okay. So shall I start teaching you with any of these factors only? Or I should start with the next, which is quadratic equations?
Ma'am, we can start with
Yes, speak again, Ifra. What are you saying?
real numbers.
With real numbers only. Okay. So we will start with real numbers. One second, let me open the PDF. Okay, so the first topic in real numbers that we study is the fundamental theorem of arithmetic. Okay, so what is the fundamental theorem of arithmetic state? Do you know this?
Yes.
Tell me what is the fundamental theorem of arithmetics? If are you there, do you hear me? Have you studied this theorem before?
Yes, yes, ma'am, I have.
Yeah, so tell me what is fundamental theorem of arithmetic?
Yeah, the fundamental theorem of arithmetic, it's about prime factors and
Okay, what are composite numbers and prime numbers? Do you know what are composite numbers?
yes,
Tell me what are composite numbers?
composite numbers are those which have factors more than
Prime numbers also have factors, Ifra. One, for example,
more than
13 has factors 1 and 13. So what is different in composite numbers? Composite numbers have more than 2 factors.
ma'am.
They have more than 2 factors.
Yes,
And what about prime numbers? Prime numbers have
they have less.
only 2 factors, which is 1 and the number itself. Okay? And what are these factors? 1 and the number itself. For example, you have 2, 3, 13, 9. Not 9, I'm sorry, 19. 90, etc. Okay, these are all prime numbers. So what are the factors of 2, 1 and 3, 1 and 13, 1 and 30, 19, 1 and 9. So prime numbers have only 2 factors, out of which one of the factor is 1 and the other factor is number itself. Okay, Fra. And what are
Yes,
composite numbers? So composite numbers are, for example, I have 4. So 4 has a factor 1, 2 and 4. It has more than 2 factors, 3. It has 3 factors. So it is a composite number. Any number that will have more than 2 factors is referred to as a composite. So what does the fundamental theorem of arithmetic say? That every composite number can be represented as a product of its prime factor. What does it say? That every composite number can be expressed as a product of its prime factors. Right? For example, I have 25. Okay, now 25 can be expressed as 5 into 5. This is the prime factorization of 25. So it is represented as 5 into 5. So 25 is a composite number and 5 is a prime number. So composite number is being represented by a product of its prime factor. Okay, similarly, I have 24. So 24 can be represented as 2 into 2 into 2 into 3. Right? So again, 2 is a prime number, 3 is a prime number, and 24 is a composite number. So again, 24 is being represented as a product of its prime factor. Do you understand now? What is the fundamental theorem of arithmetic? It says that it basically talks about prime factorization. Okay, now related to this is the concept of HCF and HCF.
Yes.
Now, what is the meaning of HCF and LCM? Very easy. We've been studying this since the lower classes. So HCF is basically the highest common factor.
Factor and LCM means least common multiple.
Yeah, it is the least common multiple. Now, these are the full forms, which itself are the definition. Highest common factor means basically you have two numbers, and for example, you have 12 and 18. Okay. Now I ask you to write the factors of 12 and 18. Now 12 can be written as 2 into 2 into 3. Right? And 18 can be written as 2 into 3 into 3. Isn't it?
Yes.
Okay, now what are the common factors? First of all, what are the common factors here?
2 and 3.
2 and 3. Okay, so 2 is a common factor, 3 is a common factor. Now you look at this thing. First, you will identify the common factor. Now you identify in which of the following is the least power of the common factor there. For example, here, see the common factor is 2. In the first one, the power of 2 is, it's 2 square and 3 to the power 1. And here it is 2 into 3 to the power 2. So you will take the lowest power of the common factor. So where is the lowest power of the common factor here? This is the lowest power, 2. So you will take 2 and now you multiply with the lowest power of 3. So where is the lowest power of 3? This is the lowest power of 3, which is 3 to the power 1. So you multiply 2 to the power of 1 with 3 to the power 1 and you get 6. So what is the highest common factor of 12 and 18? 6. Because 6 is a factor of 12 also. 6 is a factor of 18 also. Understood?
Yes.
Okay. Now if I talk about to find the LCM of 12 and 18. Okay, then what we will do? This was the HCF.
We'll do the prime factorization together.
No, by like this method only. Yeah, like this method only. Like you do prime factorization, you get 2 into 2 into 3. And for 18, you get 2 into 3 into 3. Right? So now
Yes.
what you do? First, you identify the common factors.
Yes.
What are the common factors? And you take the highest power of common factors. Now you do the opposite thing. You will take the highest power of common factor. So where is the highest power of common factor? Here. It is 2 to the power of 2. And here it is 3 to the power of 2. 4, 9, 36. So the LCM is 36. Okay. So what do you do in HCF? To find the HCF of any 2, 3, 4, 5, any numbers, whenever you are finding the HCF, you will do the prime factorization. You will write the factors. You will identify the common factors. And then you will identify the common factor where it is having the lowest value. For example, you have 2 as the common factor somewhere. And 2 has a power of 5 also, 4 also, 6 also, 3 also. So you will take which is the lowest power of it. 2 to the power 3 is lowest. So you will take 2 to the power of 3. While in LCM, what you will do? You will take only the highest power. Alright. So
Yes.
practice some questions based on this. Okay, now there is first of all a very important question. You have a number 4 to the power n. Okay. And now what you have to do, check the numbers 4 to the power n, where n is a natural number. This n is the power is basically a natural number. Natural numbers are, what numbers are called natural numbers?
Other numbers which start from 0.
Then what are whole numbers?
Oh, I mean, sorry, the numbers which start from 1 and the numbers are the numbers which start from 0.
Natural numbers are the numbers starting from 0. So 1 and then till infinite, you have natural numbers. Okay, so here 4 to the power n, and n is a natural number. And what you have to do, it's given in the question, check whether there is any value of n for which 4 to the power n ends with the digit 0. Okay, So you have to check and tell me, is there any value for n for which 4 to the power n ends in digit 0. Okay. So what do you do? First of all, in order to for any number to end in digit 0, what should be the factor over there? It should have 5 as its factor.
Yeah.
Isn't it? See, for any number to end at digit 0, for example, you have 450, any random number. It's ending in 0. So it will have 5 as its factor. Do you know that the divisibility rule for 5 is a number should end in 0 and 5? Do you know
Yes.
this rule? Okay. So for any number that is ending in 0, obviously it has 5 as its factor, right?
Yes.
So that means whatever number is given to you, like this 4 to the power n, this should have 5 as its factor, right? If it has 5 as its factor, then only it can end in digit 0. If it does not have 5 as its factor, then how will it end in 0? It can't. Are you able to understand this point or not, Ifra?
Yes.
Okay. So let's try to break down 4 to the power n. So when I break down 4 to the power n, it is, see, 4 is written as 2 into 2, which means 2 square. So 4 to the power n is written as 2 to the power 2n. Now over here, nowhere can I see 5 as the factor. The factor of 4 is 2 into 2 into 2 into 2 and so on, right? Whatever my number is, it does not have 5 as its factor. That means there is no value for n for which 4 to the power n can end in digit 0. There exists no such value. Okay? If there was any value, then it would have 5 as its factor. But since the 5 is not a factor of 4 to the power n, hence it cannot end with digits. Understood?
Yes.
Okay, so now we come to the question for LCM and HCF. You have to find LCM and HCF of 6 and 20 by prime factorization. Can you do this now on your own?
Yes. Yes.
Okay, try to do it. Yes, if you're done, what's the answer?
This one I'm done. The HCF is 2 and the LCM is 60.
So if you're done, you have to tell me that you've done. Okay, so 6, the prime factors will be, what are the prime
The
factors?
2 and 3,
And for 20,
2 into 2 into 5. 2 square
2,
into 5.
okay. So what will be the HCF?
2.
How?
We'll take common from there because 2 is common in both of them.
Yeah, and lowest power of 2 is 1. So 2 to the power of 1, that means 20, and the LCM?
LCM is 60. We'll take 2 from 6 and then we'll take 2 in 2 into 3 we'll take from 6 and then we'll take 2 square into 5 from.
So how do you get 60, Ifra?
We'll multiply 2, 2, 3 and 5.
Why did you multiply 2, 2, 3, and 5? I want an explanation for that.
Because 2 is first of all it's common and 3
Okay,
is
2 is common, fine. But here for HCF we took only 1, 2. Then why are you taking 2 2s in LCM?
because that's the one being left over there.
No,
There's like
I
2
didn't.
square. For like 20, we have 2 square into 5, right?
Yeah.
And then we're gonna take 2 square as 2.
You're not giving the correct explanation. See, what we have is, I told you in LCM we take the highest power of the common factor. The common factor is 2. But here the power of 2 is 1 and here the power of 2 is 2. So that is why I'm taking 2 square and not 2 to the power 1. Because in LCM we take the highest power, while in
Yes, that's
HCM
what I'm saying. 2
power.
square into 5.
I know you said 2 square into 5, but what is my question, Ifra? That I wanted an explanation why you're taking 2 square and not 2 to the power 1. Because in LCM we take the highest power. You should know these. Okay, there is a distinction in HCF and LCM. That is the main thing. So you take the highest power 2 square and then you take the remaining factors. So remaining factors are 3 and 5. So this comes out to be 60. Okay. So now I shall be sharing a few set of questions with you. You can attempt those questions. 1 second.
I've already given a diagnostic test with Namrata ma'am.
You've given the diagnostic test already?
Yes.
One minute. Let me just check, okay? Then we'll proceed.
Sure.
We will continue ahead with the lesson only, Ifra. Okay, so we have the next question. Okay, before teaching the next question, we have one important thing. Now, proof basically a statement that whenever you have two numbers, let's suppose you have two numbers, A and B. Now, in this A and B, when you find the HCF of A and B and LCM of A and B, so there is a relationship between LCM and HCF. Do you know that relationship?
What?
Ifra, do you hear me?
Ma'am, your voice is lagging.
Do you hear me now?
Yeah.
See, whenever you have two numbers, A and B, so when you find the HCF of A and B, and you multiply it with the LCM of A and B,
Yeah.
so it is equal to the product of A and B. All right? The HCF of A and B multiplied with the LCM of A and B is equal to the product of. Remember this. So we have an example on it, like find the HCF of 96 and 404 by prime factorization. Hence, find LCM. Okay, so first of all, you just have to find the HCF of 96 and 404. And once you found the LCM, then you will use this formula to find the, once you found the HCF, then you use this formula to find its LCF. All right?
Okay.
Okay. Please start doing it. Ifra, have you completed?
Just a minute, ma'am. Done, ma'am.
Okay, so first of all, how do you find the HCF of 96 and 404?
We did the prime factorization, and then the least degree that came was 2 power 2, which is 4. So our HCF was 4.
What is the prime factors of 96?
2 power 5 and 3.
2 to the power 5 into 3, okay, and 404?
2 power 2 to the power 2 and into 101.
Okay. So now what is common here?
2 is common over here and it has the least power.
What is the least power?
2.
2. So your HCF comes out to be 2 to the
4.
power 2, which is alright. Now you have to find the LCM as well. So how will you find the LCM now?
Of HCF into LCM equals A into B. We put the values of HCF and put A and B, which we get 4 into LCM equals what do you say, 24 into 96 into 404 divided by 4, and which we get 24 into 404, which is 9696.
Okay, so you get 96 into 400 divided by.
Yes. Which we simplified as 24 into 404.
So your LCM will be 9696. Alright?
Yes.
Understood this thing? Good. So now we move ahead. We have the next question. Find the HCF and LCM of 6, 72 and 120 using prime factorization. Okay. The numbers are 6, 72 and 120. Find the HCF also and the LCM. So try doing it.
Yes, ma'am, I'm done.
Okay, so we shall discuss the answers. First, the
HCF is 6.
factors of 6, tell me. 2 and 3.
Yeah. And factors of 72 is 2 power 3 into 3 power 2. And factors of 120 are 2 power 3 into 3 into 5. So the ones with the least power are 2 and 3.
First of all, the common factors are 2 or 3 only. So HCF will be, what is
Is
the least power of 2? 1. So 2 to the power 1 into 3 to the power 1. So it becomes 6.
yes.
And
And
the
the greatest powers are 2 power 3 and 3 power 2 and 5 power 1. We'll multiply all of them and we get 60. 360.
okay. So the HCF is 6 and the LCM is 360. Okay. Now we can also come to one thing, which is checking whether our HCF and LCM is correct or not. So on multiplying the HCF and LCM, we must get the product of the numbers, which is 6, 72 and 120. Check it once. No, wait. We have 3 numbers here, right? So that was true only for 2 numbers, not for 3 numbers. So you don't do it by this. You can just leave your answer here only, okay? You're getting the HCF and LCM correct?
I'll just check in my textbook.
No, I'm asking you. Are you getting 6 and 360 only?
Yes, ma'am.
Okay, that's correct. Good. So, Ifra, for today, we'll just keep it up till here only. We studied real numbers and fundamental theorem of arithmetics and all. In the next class onwards, we are going to start with the second exercise, okay, which deals with irrational numbers and all. We'll be looking at those concepts further. So if you have any doubts from today's class, you can ask me.
No, ma'am.
Okay. So I shall be posting one assignment for you of 2 to 3 questions in the students portal. You can just go and check it there and complete your assignment and submit it back. Okay.